Hello, I'm Simon Whistler, you're watching TopTenzNet, and in the video today we're looking at the top 10 interesting theories that are difficult to believe. Throughout history, there have been people who have tried to explain the complexity of the universe. While these theories may provide some answers to the mysteries of life, they can also be confusing and boggle the mind. Here in this video, we're looking at 10 of these theories, which are incredibly hard to understand. Number 10. The Black Swan Theory. Developed by Nassim Nicholas Taleb, a professor of finance, the Black Swan theory isn't as hard to grasp as it is to realize its implications. According to the theory, a black swan is an event that is supposedly impossible to predict, but has massive ramifications and then is rationalized with hindsight afterwards. A major black swan event was the 9/11 attacks. If it had been foreseeable that terrorists would force their way into the cockpits of passenger planes, take them over with box cutters, and then crash the planes into American landmarks, then more precautions probably would have been taken to ensure that none of those steps could have happened. Then, after the attacks, experts and pundits weighed in and tried to use hindsight to explain why the attacks happened. Eventually, it seemed as if 9/11 was inevitable because poor airline security allowed it to happen. In response to these rationalizations, airline security increased to ensure that it never happens again. Here's the problem with this type of logic and rationalization. The next major world-changing terrorist attack won't be people flying planes into buildings, because we have safeguarded ourselves against that and it won't be as shocking. It will be some other black swan event that very few people will see coming. Another example of a black swan event for many people was the election of Donald Trump. Most people did not predict him to be the Republican nominee, let alone win the presidency. The polls didn't indicate that he was anywhere near the lead, and even his own party was distancing themselves from him. However, when Trump did win the election, many of the big news organizations and the Democrats attempted to use hindsight to rationalize how he won. Essentially, the Black Swan theory is about being aware of what you're not aware of. No problem, right? Nassim's advice is to just always assume a catastrophe could happen at any time. Number 9. The Potato Paradox. Let's say you have 100 pounds of potatoes. These are special potatoes which are 99% water by weight. Now you decide to leave the potatoes out to dry because they taste better when they are 98% water. When you go to get your potatoes, how much do they weigh? Logically, one would think that they would weigh a shade lower than 99 pounds, because 1% of water would be 1.0101 pounds. Well, the actual answer is 50 pounds. That's right, by losing just 1% of water weight, the potatoes would weigh half as much. What it comes down to here is ratios. When the potatoes are 99% water, that means there is 1% solid mass. That makes the ratio of liquid to solid 99:1. However, when it dehydrates, it changes the ratio of water to solids from 98% water and 2% solids, which is a ratio of 98:2 or 49:1. That means the weight has dropped in half to 50 pounds. Number 8. Simulacra and Simulations. Jean Baudrillard was a French philosopher, and one of his most famous treatises is Simulacra and Simulations, which was published in 1981. The very confusing theory essentially contends that our reality is fake, and we are so far removed from real life that everything is hyper-real. Baudrillard even goes as far as to suggest that our life is just a simulation, and we aren't even aware of it. To illustrate his point, Baudrillard uses a very short story by Georges-Louis Borges called On Exactitude in Science. In the story, that is only a paragraph long, there is a kingdom where they have made a detailed map of the kingdom that is a scale of 1 to 1. The map is then spread out over the top of the kingdom, and after a while, people think that the map is really the kingdom. He says that our reality is pretty much just a man-made map that is covering real life. According to Baudrillard, we got to this artificial reality in 4 steps. On the website Critical Theory, they use a pumpkin to show how the steps work, so we're going to go with the same theme. Step 1. It is the reflection of a basic reality. This is an imitation that is as close as possible to resembling real life. It is a picture of a pumpkin with no special lighting or filters, just a plain old picture of a pumpkin. Step 2. It masks and perverts a basic reality. The picture has been altered to make the pumpkin look better. Lights are added and it has a nice filter, but it is still a picture of a pumpkin. Step 3. It masks the absence of a basic reality. A picture of a pumpkin pie made from canned pumpkin sitting beside a fresh pumpkin. This gives the impression that the pie is made from fresh pumpkins, even though it's canned. Step 4. It bears no relation to any reality whatsoever. It is its own pure simulacrum. This would be a picture of pumpkins with a pumpkin spice latte which contains absolutely no pumpkin at all. The pumpkin taste is made from spices like nutmeg and cinnamon. What Baudrillard proposes is that modern reality has as much realness as a pumpkin-spiced latte has to a real pumpkin. Our reality, which is constructed by the media and the government, is as real and as authentic as Walt Disney World or professional wrestling. Number 7. The Dichotomy Paradox. Zeno of Elea was a Greek philosopher who lived from 490 to 430 BC. He is mostly known for his riddles and paradoxes, and one of the most famous of them is the Dichotomy Paradox, which means the paradox of cutting in two. In the paradox, Zeno is studying and decides to take a break. For his break, he wants to walk into a nearby orchard. To get to the orchard, he has to walk halfway there, and this takes a finite amount of time. The second half of his journey can also be split into two, and it takes a finite amount of time to walk that distance as well. Then the third quarter of the journey can also be split in two. This is where the paradox arises, because the distance can be infinitely divided by 2, and that would mean that Zeno would never reach the orchard. This is because, according to Zeno, if you were to add up all the finite time over an infinite distance, you would get an infinite amount of time and distance, which means that motion doesn't really exist. At this point, you're probably thinking that Zeno is probably a bit of an idiot, or else he's really high, because if you walk from one spot to another, you do get there. Nevertheless, the paradox wasn't solved until 2,000 years later by mathematician George Cantor. He proved that it is possible to add up an infinite number of finite numbers. Number 6. Vasiliev Equations. Unless you're mathematically gifted and or highly educated in math, physics is one of the most difficult topics to understand. And one of the most complicated theories in physics, which even physicists have a hard time understanding, is the concept of Vasiliev Equations, which was developed by Mikhail Vasiliev and Efim Fracton of the Lebedev Institute in Moscow in the late 1980s. If the theory is correct, then it could explain where space and time come from. George Musser, an editor at Scientific American, decided to take a crack at explaining the theory that many physicists don't even understand. He said the theory is based on the spin of particles. Basically, all particles of the same type have the same amount of spin. For example, a photon has a rotation of spin 1, which means that it needs to rotate 360 degrees to look the same again. If a particle has spin 2, like a graviton, then it would need to rotate 180 degrees. There is also spin half, which means it would need to rotate 720 degrees to look the same. The lowest it can be is spin 0, which is the Higgs field, and it looks the same no matter how it's rotated. How high the spin could go is where Vasiliev equations come in. They contend that there is an infinite number of spins. However, physicists thought that particles with infinite spin were impossible. For one thing, it appeared to go against the leading fully unified theory of nature, which is string theory. In string theory, if there were an infinite number of spins, then the laws of nature would seize up. However, physicists have recently learned that in curved spacetime, infinite spin rates could be possible. If our universe exists in curved spacetime, then Vasiliev's theory would support an important aspect of string theory called the holographic principle, meaning that Vasiliev's theory can be reconciled with string theory. But then again, this is only if we do live in curved spacetime. Number 5. Maxwell's equations. James Clerk Maxwell was only 34 years old when he published one of the most important papers in physical science. It was called A Dynamical Theory of the Electromagnetic Field. When it was released in 1865, physicists couldn't understand the math and mathematicians couldn't understand the physical aspects of it. Because it was so hard to understand, it was essentially ignored for 2 decades. One person it did inspire was Albert Einstein, who used it as a starting point for his special theory of relativity. In fact, Maxwell was formulating ideas that eventually could have led to what Einstein discovered, but unfortunately Maxwell died at the age of 48 in 1979. Einstein wouldn't make the discovery until 1905. We won't go into a lot of detail surrounding the equations, but there are 4 which we're picturing here. They essentially explain the world of electromagnetics. The 4 equations describe how electrical charges and currents create electric and magnetic fields. It also explains how an electric field can generate a magnetic field and vice versa. However, that is just the very basic explanation of what Maxwell's equations are about. Beyond that, it is too hard to explain, and many electrical engineers and physicists still don't fully grasp it. So yeah, unsurprisingly, neither do I. Number 4. Gödel's incompleteness theorem. Kurt Gödel was born in Germany and later immigrated to the United States. He is considered one of the most important mathematicians of the 20th century, and he's also thought to be the greatest logician since Aristotle, who died 2,200 years before Gödel was born. Gödel had a few theories that are difficult to wrap your head around, but his most famous and important work, which is incredibly hard to understand, is his incompleteness theorem. According to Encyclopedia Britannica, the theorem states that within any axiomatic scientific mathematical system, there are propositions that cannot be proved or disproved on the basis of the axioms within that system. Thus, such a system cannot be simultaneously complete and consistent. So my question to you now is, did you understand any of that, or did your nose just start to bleed while you were thinking about it too? In order to understand the theory a little bit better, it's best to go back and explain what the mathematical world was like before Gödel published his theory in 1931. Before Gödel, mathematicians thought that all math theories could be solved with proofs that showed them to be correct or incorrect. An example used by the website Number Sleuth is Goldbach's conjecture, which is that all even numbers starting with 2 can be expressed by 2 prime numbers. For example, 2 plus 2 equals 4, 11 plus 13 equals 24, and 601 plus 797 equals 1398, and so on. Before Gödel, people thought that this could be proved to be correct or incorrect. What the incompleteness theorem did was show that something like Goldbach's conjecture is actually impossible to prove. This is because there are an infinite number of numbers, and if just one number couldn't be expressed as 2 prime numbers, then it would be incorrect. So that means that either Goldbach's conjecture is either true but is improvable, or it is false and falsehood cannot be proved. Essentially, what the incompleteness theorem proved is that there was a difference between mathematical truth and mathematical proof. Mathematical proof of Goldbach's conjecture is that all numbers up to 4 times 10 to the power of 18 can be expressed as a prime number. However, the mathematical truth of Goldbach's conjecture will never be proved to be correct or incorrect. Of course, this doesn't only apply to Goldbach's conjecture, but to all theories in maths. Number 3. The theory of general relativity. One of the most famous theories of all time is also one of the hardest to understand, and that is Albert Einstein's theory of general relativity. Before we can get to general relativity, there are 2 things that we must go over. The first is that in 1905, Einstein published the special theory of relativity, which basically states that time and space are linked. In fact, they are indeed the same thing, something called spacetime. And you've probably heard Doc Brown talking about that. So since they are the same thing, that means space can't be warped without warping time, and vice versa. However, the theory had limitations. Notably, it only dealt with constant speeds, and it failed to explain acceleration, and acceleration is something that everything in the universe does. Secondly, before general relativity, thanks to Newton, the belief was that objects fell to Earth because of gravitational pull. However, objects in the universe don't move because they are pulled, instead they are moved when they are pushed. Think of a rocket. It goes into space because booster engines push it into space, so the idea that gravity pulled instead of pushed was unusual in the world of physics. This is where the theory of general relativity comes in. What Einstein showed is that when mass comes into contact with spacetime, it can warp spacetime. This warping is actually what is causing gravity. Space is pushing us down on Earth. This happens because mass will always follow the simplest path in spacetime. But if spacetime is curved, mass will follow that curve toward the object with the most mass. This also means that the further you go away from the Earth's surface, the slower time goes because time is less warped. The theory of general relativity was a paradigm shift for many people in the world of physics and set the foundation for a branch of physics that is still being used today. However, it is not the only leading theory in physics, and it is at odds with the other top theory, which is number 2, quantum mechanics. Famed mathematician Richard Feynman once said, "If you think you can understand quantum mechanics, you don't understand quantum mechanics." So this entry is going to be fun. Quantum mechanics, QM, is the attempt to explain subatomic particles at the nanoscopic level. The mechanics of subatomic particles are different than the mechanics of larger objects. For example, the same rules of size and speed don't apply. Also, with larger objects, they exist at a specific time and in a specific space. For instance, you exist at this moment wherever you're watching this video, whereas the objects in quantum mechanics exist in a haze of probability. According to life science, there are 3 revolutionary principles of quantum mechanics. The first is quantized properties. According to classical mechanics, properties like position, speed, and color should exist on a smooth, continuous spectrum. However, scientists learned that some properties can sometimes only occur in specific set amounts. It's similar to a dial that clicks from number to number. This clicking of the dial is what scientists called quantized. Secondly, light, once only thought to be in waves, can actually act as both a wave and a particle simultaneously. The third principle is that matter can also act like a wave, but is usually a particle. Currently, QM is being used to study string theory and loop quantum gravity. Researchers are hoping that QM will be the key to unlocking many mysteries of the universe. Number 1. We live on the event horizon of a 4-dimensional black hole. The Big Bang Theory itself isn't exactly that hard to understand, because the name is pretty self-explanatory. Essentially, everything in the universe exploded from singularity, which was a tiny speck of infinite density. While the Big Bang Theory does explain a lot about the birth of the universe, there are several problems with the theory. For example, it doesn't explain what caused the Big Bang in the first place. Since the Big Bang was proposed in 1927, researchers have been trying to figure out a model that would account for these problems. One of the most mind-bending theories comes from the Perimeter Institute for Theoretical Physics in Waterloo, Ontario. Their theory is that our universe may be a 3-dimensional wrapping around a 4-dimensional black hole's event horizon. Totally makes sense, right? Or maybe we do need to back up a minute. According to the Big Bang Theory, our universe exploded out of a singularity. Well, singularity is also found at the center of black holes, and in our 3-dimensional universe, black holes have a 2-dimensional event horizon. However, if a black hole had 4 dimensions, something humans can't conceptualize but is theoretically possible, then the event horizon would be 3-dimensional. Their theory is that our universe exists on the event horizon in a giant 4-dimensional black hole, and our Big Bang was actually a 3-dimensional mirage of a collapsing star in a universe that is profoundly different from our own. After the collapse, our universe expanded and essentially wrapped around the event horizon. If their theory is correct, and so far math has yet to disprove it, it could also mean that every time a black hole is born in our universe, then it could spawn another 2-dimensional universe. So I hope you enjoyed that video and found it suitably mind-bending. If you did, please do hit that thumbs up button below, and don't forget to subscribe for brand new videos just like this every day of the week. Also, over there on the right, a couple of other videos that you might enjoy if you enjoyed this one, and as always, thanks for watching.